Okay, so here we go. We're looking for the positive root of this. Okay, so there's several dilemmas in the beginning. What does positive root mean? Positive root means what's crossing on the positive x-axis. So over here. All right, and then we don't have a function given to us. So we need to create a function that we're finding a root of. So that means we need to get it equal to 0. So getting it equal to 0 gives us this that I'll set equal to 0, or this that I'll set equal to 0. So these are just negatives of each other, right? This is moving the negative, or the x to the fourth over to the left-hand side. This is moving the negative, or the 2 cosine x over to the right-hand side. They're both functions that I would set equal to 0. So would it matter which one I'm using? Well, think about it. They're just negatives of each other. So if this was one function, taking the opposite of it would just be the mirror image across the x-axis. The root doesn't change. The root doesn't change, so no matter which one I'm looking at, and that's all I need to find is the root. All right, so you need to put in for your y1 this 2 cosine x minus x to the fourth, or the other one. I'm just going to use this one. That's your y1. You're going to need to graph this on your calculator to look to see where it crosses the x-axis, right, where the x's are positive. To me, it looks like it crosses near 1. So I'm going to use 1 store x as my first guess. Then I need to make sure I have as y2 my derivative, which is negative 2 sine of x minus 4x cubed. Then you've got the formula memorized, right? So it's, well, you've got it from above. Here it is, x minus y1 divided by y2. Store x, put that in with your 1 stored as x. And if I use 1 storing as x, I get my x2 is 1.014183606. Then my x3 is 1.013957673. And my x sub 4 is 1.013957614. Okay, there it is. I have my answer to 6 decimal places, so that is my root. All right, so let's move on to the idea of it. Making sure you understand the implementation of what we're doing after we just worked through many examples of using the calculator. I want to make sure you remember what it meant to do Newton's method. So Newton's method says take an x value, make a tangent line at that x value to the function. So this x value you're choosing has to be close to the root that you're trying to approximate. That's the root I'm trying to approximate. This one is fairly close. I'm just drawing it a little farther away so I can draw it. You make a tangent line at that point. There's my tangent line. And x2 is the root of the tangent line. The root of the tangent line should be closer to the actual root you're trying to find than your original guess. So yes, this works. So, oops, I forgot to draw one. Okay, so here's my function. So let me draw like this. So here is, I'll put 2 here, and I'll put 4 here. Okay, so is x1 equaling 4? Is this a good choice to approximate the root? Looks kind of far away. And then what happens when I go and find the root of the tangent line? So the root of the tangent line is x sub 2. So I'm going to try to make it look like it's crossing or tangent at that point, right? Oh my goodness, there it is. That would be my x2. That does not look like a good choice. And then if I went even further, making the tangent line at that next point, that's really bad. So this is not a good choice because the root of the tangent line is not closer to the root of the function. So that would be the answer for part A. All right, so now let's look at part B here. Is 2 a good choice? So if I use 2 as a choice for my x sub 1, my first choice, where I'm going to make a tangent line, and I make a tangent line, this would be my x sub 2, the next root of the next tangent line. Is it closer to the actual root I'm trying to approximate? Yes, it is. So this is a good choice. All right, so I've tried to give colors here to explain what's happening in this next question. So suppose this line, y equal 5 minus 4x, and that's this blue tangent line. Suppose this is, right, the tangent line to the curve of f of x, the red f of x, at the point 3. So tangent line has to occur at a certain point, and so that it's occurring at the point 3. So tangent line to the curve, the red curve f of x at the point x equal 3. All right, so I'm trying to approximate what the root of the function is, correct? That's why I drew a tangent line. So what is the next approximation x sub 2? Well, x sub 2 is the root of the tangent line that I've drawn. Can I find the root of the tangent line? I do believe you can. So if I want to find the root of the tangent line, I'm finding where 5x minus 4 is equal to 0, so that's 5/4. That is x sub 2. I'm sorry, I said it wrong. 4/5. 4/5 is the root of the tangent line, and that is x sub 2. Okay, I've given you another one just like it. So here, this 3x plus 2 is the tangent line to the curve drawn at x equal 1. You always have to know where the tangent line is being drawn. There's the red f of x curve. So if this is the tangent line, and this is my x sub 1, what is my x sub 2? Well, x sub 2 will be the root of the tangent line. So the root of the tangent line of 3x plus 2 will give me x equal negative 2/3. So my x sub 2 is negative 2/3.